everyone, welcome back to WayKen Rapid Manufacture channel. My name is TJ. If you're in the machining business, you probably know that CNC machining is about a lot more than just cutting and milling to the joint specs. We are working with complex shapes or parts that need to be extra hard. Material stress can easily cause warping, bending, or mess with the accuracy of the final part. So how do we solve this problem? Heat aging treatment is basically the process of heating up the metal and hold it at a specific temperature for a period of time. This allows the alloy element in the metal to separate or the crystal structure to change. Not only does this improve the strength, hardness, and the stability of the metal, it also helps release internal stress in the material, which can prevent those issues that cause parts to warp or deform. In the end, this makes machining more precise. Now let's take a look at a real project. This part I have here is made from steel 45. It's a flat structure with recesses on both sides. The flatness on this surface needs to be within 0.02, and the parallelism between these two sides should be within 0.03. There are also two precision holes with an accuracy of H7 tolerance, and the hole spacing tolerance is plus and minus 0.02. Overall, the hardness of the parts needs to be between HRC 30 and 34. Although steel 45 has great mechanical properties, during the machining process, the material tends to accumulate internal stresses, which can lead to warping, bending, and even affect the part's accuracy, especially flatness and parallelism. If the heat treatment isn't properly controlled, or if the heat treatment in the machining process aren't well planned, the flatness of the part could end up at 0.07 or even worse. The hole spacing between the two precision holes can also easily fall out of tolerance. So how do we solve this problem? We follow a three-step process during machining. First, we did a quick rough cut to get a basic shape, leaving about 0.1 mm of extra material for the final finishing. At this stage, we've removed most of the material, but the part isn't at its final precision yet. The main goal here is to reduce the build-up of strength for the next step in the process. Next, the part goes through heat aging treatment. We use 3 stages of heating and cooling to gradually release internal stresses while also improving the material's hardness and strength. After the heat aging treatment, the part may experience some degree of deformation, but because the internal stresses have been effectively released, its dimensions become much more stable. After that, we just need to do some precision finish to make sure the part's final shape matches the joint exactly. Following this approach, the final parts we produced finally meets the joint's requirements, with all the dimensions kept within tolerance. Through today's example, we can see how crucial heat aging treatment in metal part machining. It not only helps us tackle issues with internal stress and deformation, but also ensures that we can meet high precision requirements. Thanks for watching. If you found this video helpful, don't forget to give us a thumb up and subscribe. See you next time. Bye-bye.